The gray panel from yesterday still loomed in my thoughts. Breakers had revealed themselves not as switches, but as guardians. Today, Harris promised something different. It's not just wires in our hands, but numbers in our heads. He called it the math of power. We gathered around the bench, notebooks open, pencils sharpened. Harris tapped the panel board like a teacher striking the blackboard. Harris, yesterday you met the breakers. Today, you prove you can feed them. Every breaker has a rating. Every panel has a capacity. If you miscalculate, wires overheat, insulation burns, and homes turn to ashes. He held up a breaker. The number 20 shone on its handle. Harris, apprentice, what does this mean? I raised my voice. John, 20 amps. The breaker protects a circuit that carries no more than 20 amps. Harris, correct. Amp rating is current. Voltage rating is pressure. Together, they define the breaker's strength. He spun the breaker in his hand like a coin. Maria. And what happens if you place a breaker too large for the wire? Maria. The wire overheats before the breaker trips. Harris, exactly. Breaker protects the wire, not your laziness. Kevin whispered under his breath. Kevin. Bigger breaker, bigger power. Why not? The foreman's eyes snapped to him. Foreman, say that again, and you will pack your tools. A bigger breaker on small wire is murder by arithmetic. Kevin lowered his gaze. No one laughed. Harris wrote numbers on the board. Harris, load calculation. Lighting, appliances, HVAC, every load must be counted. NEC gives formulas. You must size feeders, breakers, and panels to match. Tell me, John, why do we calculate load? John, to ensure the breaker capacity is not exceeded. To prevent overheating and tripping. To design circuits that live, not die. Harris, good. He paced slowly, voice low, but sharp. Harris, overcurrent means too much current. Fault current means current on a path it never should take. Arc fault means fire leaping through air. Ground fault means current diving to earth. Breakers isolate these faults. That is fault isolation. They will remember it, or the inspector will remind you with red ink, Maria asked. Careful. Maria, how do we know the breaker is right for the load? Harris pointed to the label inside the panel. Harris, the panel itself tells you breaker spaces, maximum amperage, main rating. You cannot exceed what the manufacturer states. That is net. That is law. He pulled out a double pole breaker and set it on the table. Harris, single pole equals 120 volts. Double pole equals 240 volts. Tell me, Kevin, why do we need a double pole breaker? Kevin, for larger appliances, ovens, dryers, HVAC units, to carry 240 volts safely. Harris, correct? Even you can learn when numbers speak louder than pride. The foreman stepped forward with a clamp meter and a load schedule. Foreman, calculate this. Kitchen has two small appliance circuits at 20 amps each. One lighting circuit at 15 amps and a range at 40 amps. Total, we scribbled quickly. Maria answered first. Maria, 95 amps. Foreman, and the feeder is rated for 100 amps. What does that mean, John? It means the load is near the maximum. Any mistake, any extra load, and the breaker will trip. You must design with margin. Foreman. Exactly. Code is not about chance. It is about margin. Harris then showed us a tandem breaker. Two handles sharing one slot. Harris. What is the danger of overloading a panel with tandem breakers? Maria. Exceeding the designed breaker capacity. The bus bar overheats. Harris. Yes. The panel label is scripture. Break it, and you are out of compliance. He handed me a torque screwdriver and pointed to a lug. Harris, terminate this feeder. Correct strip length. Proper torque. Then prove it with your meter. I stripped, landed the conductor under the lug, tightened carefully to the listed torque. The continuity tester beeped clean. Harris tugged. The joint held. Harris, good. Loose as heat. Too tight as broken strands. Balance is safety. He turned back to the class. Harris, what is the dead front? Maria. The cover that protects live parts. Harris, correct. And why do we label every breaker? John, to identify circuits. To prevent chaos in emergencies. Harris, good. What PPE must you wear when working on panels? Kevin, eager to recover, answered. Kevin, gloves, face shield, insulated tools. Harris, yes, not sneakers, not sunglasses. Protection that can stand against arc flash. The foreman slammed his hand against the panel cover. Foreman, and what is arc flash? John, a dangerous explosion of energy from an electrical fault. Foreman, correct? Tomorrow you will meet it face to face, in the lesson, not in the hospital. The words froze the air. Arc flash, explosion. We imagined fire erupting from the panel, steel melting, flesh burning. My chest tightened. But deep down, I felt ready. As the sun set, I wrote in my notebook. Breaker rating equals amps and volts. Wire size must match breaker size. Overcurrent, short circuit, ground fault, arc fault all answered by the breaker. Load calculation prevents disaster. Panel labels are law. Torque every lug. Never oversize. Never guess. I closed the book. Numbers had never felt so heavy or so alive. Tomorrow would bring the final trial. The arc flash and the inspector's judgment.